Good morning, I'm Jian Hui here.
I'm Johnny.
And I'm Fang.
So today we'll be conducting an experiment by creating a microscope of our own design to measure hair diameter. So instead of using a traditional microscope, what we have done is to create a microscope of our own variation. Our microscope mainly focuses on using light refraction to obtain a magnified image of the hair so that we are able to measure the diameter.
So how do we go about doing our experiment? Firstly, we have used an iPhone as the light source to shine onto the hair, which will pass through the lens and project a magnified image onto the screen, which we'll show you later.
For the lens used, we have used a convex lens of focal length 40 centimeters. Then the lens will be attached to a stand.
Next, what we have here is a strand of hair that we taped onto the cardboard over here after cutting out a window in the middle. We also taped the cardboard with the hair attached onto the stand so that it will be on the same level as the light source and the lens over here.
Lastly, we will need a white screen to project our image on. Okay, so how do we go about conducting this experiment? Firstly, we will need a dark room, so I'll go turn off the lights now.
Next, we'll need to turn on the light source, which is the iPhone here, and adjust the distances between the lens, light source and the hair to get a clear and magnified image onto the screen as shown over there.
Next, we will then use a meter ruler to measure the magnified version of the hair on the screen. From then on, we can use further calculations to then obtain the actual diameter of the hair. Today we'll be setting up an experiment to measure hair diameter by using a microscope of our own design. So instead of using a traditional microscope, what we have came up with is this, our very own setup.
Alright, so how do we go about measuring the diameter of a hair with our setup? Firstly, we have this optic bench here, which helps us hold in place all our different parts of the experiment. It also shows us the distance between the laser, the hair, and the light sensor here, using this printed ruler on the optics bench.
So for our light source, we have decided to utilize this red diode laser with a wavelength of 650 nanometers.
Next, we have gotten a hair from a willing participant and we taped it onto this cardboard here with a window cut out in the middle. We also taped it onto this holder and placed it in between the laser and the light sensor here. Our experiment is a variation of the famous Young double slit experiment. But instead of using the double slit like this, we used a strand of hair which acts as the solid part between the two slits. So the diameter of the hair is the distance between the two slits, which will cause diffraction to happen.
Then for the last apparatus that we'll be using is this light source, where you'll be able to detect light from the laser, and after diffraction with the strand of hair, it will be shown on the sensor. Next, we will be conducting our experiment. Okay, so now I'll be showing you how to conduct the experiment. Basically, you must set up the experiment shown here. The following apparatus will be arranged in this manner. Basically, the cardboard with the hair will be in the center of the light source and the light sensor. Okay, so what we do now is to align the cardboard with the hair with our laser so that a diffraction pattern will be formed on the light sensor. If nothing shows up on the light sensor, if such a pattern does not show up on the light sensor, it means that the hair is not vertically aligned and you must adjust it. Okay, so we will take various measurements using the ruler on the side of the optical bench, so that we are able to use these calculations to get our final result, which is to measure the diameter of the hair.